All right, dude, we are live. What's up, guys? This is Dem Keys, and today um, we're gonna be doing some browsing, preparing my shopping list for shopping. I have to uh, I have to place an order on AliExpress for various items, and I haven't prepared my list all the way. So there are um, certain gardening related, or let's say plant related parts that I have to buy. Uh, Mostly sensors. There's moisture sensors, temperature sensors, humidity sensors, water level sensors, and there were a few more advanced ones, but like I don't think I'm going to be going into those because, well, for one, I don't need them right now, but um, also what? Oh, also, they tend to be a little on the pricey side. If you want to get, ones that work properly and give you accurate results and stuff. So I'm not going to be going into those, but I will be looking into some of the simpler ones. And other than that, I'm also there's also a couple of other things that I want to buy, like a piezo electric speaker, those small, what do you call them? Those small buzzer kind of speakers that you get in those and cheap. What example should I give? Like you know those electronic greeting cards, the ones where you open the greeting card and then there's some music playing. That that music is usually done through a piezoelectric speaker. And turns out you can actually power these speakers using a microcontroller safely. You can power these speakers safely through a microcontroller. You don't need to worry too much about the speaker pulling too much current and damaging one of the pins or something like that. So for very basic audio, I figured I would start with something like this. And what else? Yeah, I might look into buying tiny speakers and amp modules along with a simple mic and a mic module. If not, if not speaker and amp module, then I definitely want to do the mic thing. The speaker thing isn't that important right now, but I definitely want to look into getting a mic and a mic module. Usually they'll come as like one set. I forgot um, exactly what it was, what the module model number was. Other than that, I also need to buy some project cases, simple cases in which I can put, in which I can assemble various types of circuits and like just place it in there. Just a nice very general purpose case for whatever type of project I'm working on. I don't exactly know what I'm looking for when it comes to a project case. I just know that I need something very general purpose that I can later modify, in whatever way I need to. So, okay, let's say AliExpress project case. Right, so you get these simple oh, okay. I think I see something that I might find useful here. There's waterproof, black and white, housing instrument case, ABS plastic, project box, storage case, electronics. Okay, so we're getting this for um just a second. Okay, we're getting this for like around $1, $1.50, maybe $3. Give me a second for this as well. Okay. Yeah, not even $3. Yeah, yeah, not even three. It'll be like 2.5 between. So okay, it could be anywhere between 1.5 to $2.5. Uh, then what else? What else? Oh yeah, okay. I can start writing these down actually. So I'm gonna be visiting the website, the shopping website on a different machine because if I do it on the machine that I'm streaming on, things are gonna get really slow. So I'm just looking at these cases, and I actually what I'm looking for is a sort of assortment of these cases. For now, I think I just want to write down their I just want to write down their prices, and then later on I'll buy them. So I can keep maybe let's say uh, I can keep maybe $5 for buying a couple of these cases. I'll have to see. I need to do some research on the type of material that they're made of because I remember having a conversation with. Oh, you know what? I can open up a new conversation with Gemini right now and talk about this. So I also want to start writing down the prices so that way I can um, get a sort of total of how much this is all going to cost, and then I can remove whatever is not required. Speaking of removing stuff, I probably don't. I probably don't need the clip-on mic right now. I need the foam dispenser. PSU power cable, I don't think I'm going to need it right now at least. I can save some money by not buying that. Another thing that I just found, which I was actually looking for this as well. So I was looking for level shifters. But here I found okay. So I was looking for level shifters to shift from 3.3 volts to 5 volts, or from 5 volts to 3 volts, from 5 volts to 3.3 volts. So like I kind of wanted something that goes both ways, and I wasn't sure exactly what I was looking for. I was like, can I actually get them in one chip, or will I have to buy two separate chips? And then I came across this thing, uh, logic level converter. Most of the stuff that I'm going to be doing is actually, so this mentions logic level, right? I don't think this applies to something like PWM, where you're getting an analog signal. Though I think I can do some research on this as well. For now, though, let me add it here. Um, so I'm looking for level shifter. However, instead of that, okay, I can add in the bracket logic level converter because this is exactly what I'm looking for. Um, this, by the way, this is the chip that I'm looking for, and yeah, it does mention that it's bidirectional. I wonder how you control what how you control um how you tell it that you want to go from high level to low level or low level to high level. Um yeah, yeah. I'm curious about that. But yeah, I will be ordering one of these. Actually, okay, now that I am here, let me also take a look at the price for this. So, logic level converter. Yeah, let me also mention 5V, 3V. Okay, nice and cheap. Looking at this, I can say this would be anywhere between, wait, let me look for something that has a higher number of orders. Okay, so a safe bet. Wait, that's for 10 pieces? That's for 10 pieces in a bundle deal. 10 pieces, 4 channels each. It mentions I2C as well, which is interesting. Where exactly is the... Hold up, I need to see one of these chips. Yeah, how exactly is the communication happening? Why is it mentioning I2C? Well, anyways, I'll place the order for this. Hopefully I get them with, proper placement, as in, hopefully the components on it are placed properly. It says 3.3V to 5V logic converter. Okay, so and so connects to this. It says 3.3V to 5V, but it also says bidirectional. So it says, okay, take the high voltage, 3.3V, take the high voltage and low voltage, ground from system connects to ground pin, package includes so and so. Right, okay. Uh, I'm okay. I do microcontroller dev with ESP32 and Rust. Um, I have found situations where um, sometimes 5V is involved, and I either have to step down from 5V or step up to 5V. I found something called a logic converter online, a logic level converter, I believe. Yeah, logic level converter online. Can this help with what I'm looking for, looking to do? And does this go both ways or just one way? In the world of ESP32 development, especially with Rust, where you are likely to aim where you are likely aiming for high precision and memory safety, dealing with 3.3V and 5V divide is a very common hurdle. The short answer is yes, a logic level converter is exactly what you need for signals, but it's not for power. Signal versus power, the big distinction. Before using one, it's critical to distinguish between these two scenarios, logic level shifting and voltage regulation. Okay, logic level shifting. This is common for I2C, SPI, UART, etc. If your ESP32 if your ESP32 3.3V needs to talk to a 5V sensor, an LLC converter, an LLC converts the high/low voltages so the chips can understand each other without blowing up the ESP32's pins. Okay. Then voltage regulation. If you need to physically power a 5V component from a 3.3V source, which is step up, I probably shouldn't have said step up. Okay, yeah, step up does, though, yeah, this kind of also taught me because I was assuming that I could use it for powering things. But yeah, okay. If you need to physically if you need to physically power a 5V component from a 3.3V source or power the ESP32 from a 5V battery. An LLC cannot do this. You need a buck down converter or a boost converter. Oh, okay, this is for a power source. Okay, all right. Does it go both ways? Most modern LLCs sold for hobbyist electronics are bidirectional. They typically use a MOSFET based circuit that allows data to flow in both directions. This is particularly important to protocols like I2C, where the data line SDA must switch between an input and an output constantly. How to identify them? Bidirectional usually has pins labeled HV, LV. These are perfect for I2C and general GPIO. Unidirectional, these use buffer chips or voltage dividers. They only work in one direction, example 5 volt to 3 volt only. These are less common in modular breakout boards, but common in DIY resistor circuits. How to wire a typical LLC. To get this working, okay, hold on. So I'm trying to think of situations where I would choose one over the other. I understand the concept that these chips are mainly meant for logic level conversion, as in as in sending data, sending and receiving data and like pulses of data and stuff. These are not meant for continuously powering something. Though I guess that's where the concept of digital versus analog comes in, because when you're powering an ESP32, it's analog, it's not digital. Like the powering that's happening there is analog, it's not digital, right? I think so. Yeah, yeah, it's analog, it's not digital. The ESP32's GPIO pins do put out digital signals, but hold on. Let me open up my stream. Oh, okay. Right. Uh all right, I can ask the question here. Well, okay, yeah, it did say well, Gemini is explaining to me how to wire a typical LLC. Okay, so connect the low voltage pin to the ESP32's 3.3V pin, then ground. Connect to common ground. High voltage connected to the 5V supply, then LV. Oh, wait, yeah, okay, there's HV over here and LV, and then there's these numbered HVs and LVs. And each of these also has their ground. So the main voltage comes to these, and then the logic is kind of like spread out through these. Note for Rust devs, since you're using Rust, remember that timing is often more precise. While LLCs are great, they do add a tiny bit of propagation delay. For standard I2C, it's negligible, but for very high-speed SPI, you might need to check your logic analyzer. When do you not need one? When it's 5V to 3.3V one way, you can technically use a simple voltage divider, which is two resistors. It's cheaper, but it only works for stepping down, not up. 3.3V to 5V. Some 5V devices are 3.3V logic compatible. Uh, they they powered by 5V, but they see 3.3 as a 3.3V as logical high. Check your components data sheet for so and so, so and so, so and so. If so and so is less than 3.3V, then you don't need a converter to talk to it. Okay, so I understand. Wait. Okay, so I'm trying to understand um, the powering versus logic thing. I'm guessing when, how should I put this? I'm guessing one way to think of it would be analog versus digital. Hold on. Uh, yeah, versus digital. Dude, I could have this conversation with, yeah, hold on. Actually, no, if I do that through the other Gemini, then I might run out of my usage data. Never mind. Um, Not my usage data, my usage limit. Okay, though, am I gonna be using the thing? No, it's fine, it's fine. Um, I'm guessing one way to think of it would be analog versus digital, and I'm guessing powering an ESP32 is talking about analog um, signals, while um, sending data out of a GPIO pin is talking about digital. Also, um, would the signal out of a PWM pin be considered analog or digital in this case? Okay, that is a very logical way to think about it, but in electronics, the term power and logic actually refer to how much energy the electricity is carrying versus how much information it is carrying. Okay, it's less about analog versus digital and more about fuel versus instructions. Power versus logic, the fuel versus instructions. Think of your ESP32 project like a car. The power, which is the fuel, this is the high current electricity that makes things move or turn on. When you power an ESP32, you are giving it the raw energy it needs to stay alive. This is almost always DC, as in direct current, at a steady voltage like 5V from USB or 3.3V from a regulator. Okay? Then logic, which is instructions. These are signals sent over GPIO pins. They carry very little energy, just enough for another chip to see them. They are the commands telling a motor to turn or a sensor to send back a temperature reading. Crucial rule. A logic level converter is like a translator for instructions. It is too weak to carry fuel. Okay, I understand what I understand now what Gemini is saying, but I kind of want to dig deeper into this thing about, yeah, I feel like I should have this conversation through this Gemini instead. Where is it? Here, right? Oh, wait, I need to open up a new instance of Gemini. So let's do scratch stuff, empty, open up Gemini. Are you guys able to see this Gemini instance? I'm not sure. Yeah, you are. Okay. In the meantime, we can probably go to a different thing while that opens up. And then we can start this conversation. And then I can ask the same question again. And then we can continue the conversation. Okay, that's taking some time to open up. In the meantime, let me hydrate and yeah, I'll be back. Okay, let's see. Okay, great. Now, because I'm a little, yeah, I think we're good. Stop. Let's use the lighter version of the model before doing this. So let's go for flash, or I think I can go for flash light because this is not meant to be doing anything heavy. So we can probably go for flash light and we get a decent amount of mileage out of it. Give me a second. Okay, yeah, I think we should be good. Wait, Flashlight is able to do a Google search? I didn't know that. Really, Flashlight is able to do a Google search. That's interesting. Okay, cool. Uh, all right. A logic level converter can indeed do so and so, so and so. Okay. The most common so and so thing. Okay. These converters typically use so and so thing. All right, great. Okay, I'm trying to understand the powering versus logic. So let's drop that. Oh, also, in the meantime, let me note down the price of this logic level converter. So I think, I mean, yes, 10 pieces, definitely more than enough, more than what I need. I'll take it. Um, it says it's bidirectional, and I'm assuming I need to know how you would do the bidirectional communication. Okay, let's read the answer here. You're on the right track with the analogy, though it's more nuanced than a strict analog versus digital split for powering versus logic. Powering versus logic signals. Powering. This refers to providing the necessary voltage um, and current for a device like your ESP32 to operate. The ESP32 needs a stable DC voltage, typically 3.3 volts or 5 volts fed into a regulator to power its internal components. This voltage level itself is a continuous electrical quantity, but in the context of powering, it's about providing the energy for the chip to function, not necessarily for communication. Okay, then logic. This refers to the discrete voltage levels used to represent binary states such as 0 or 1, low or high, in digital communication. When pins on your ESP32 are used for I/O to communicate with other components, they use logic levels. For the ESP32, these logic levels are typically 0 volts and 3.3 volts. Analog versus digital signals. Analog signals, these are continuous signals that can vary smoothly over a range of values. Think of a smooth sine wave or a gradual change in a potentiometer's resistance. Digital signals, these are discrete signals that can only exist at a specific time. No, at a specific that can only exist at specific predefined levels, which is high or low. Okay, that makes sense. For most microcontrollers, like the ESP32, there are two primary levels, low and high. Applying to your examples, powering an ESP32, powering the 3.3 V or 5 V power supply is about providing a stable voltage level for the chip to run. While voltage is an analog quantity, in this context, it's about meeting the power requirement, not about sending a communication signal. Sending data out of a GPIO pin. When a GPIO pin is configured as an output and sends a digital signal, it switches between its low and high states. This is digital communication. You're sending distinct on or off bits. PWM PWM pin output. A PWM signal is technically a digital signal. It works by rapidly switching a digital output pin on and off. Oh, I didn't realize that. Okay. However, the width, which is the duration of the on pulse relative to the off pulse, is varied. By changing the duty cycle, you can control the average voltage that reaches a component. For example, a 50% duty cycle means the pin is high for half the time and low for. Oh, okay, this is a timing thing being described. Yeah, I remember doing this in MicroPython, where you would be specifying like the duty cycle kind of thing. Like this dictates this kind of dictates the let's say if you're trying to blink something, this kind of dictates how much of it is going to be high, how much of it is going to be low. And I believe you can make this small enough that it goes high and low multiple times in a second. I think it was something. Okay, let's read this. A 50% duty cycle means it's high for half the time and low for half the time, resulting in an average voltage that's half of the high voltage. This allows you to simulate an analog output, for example, to control the brightness of an LED or the speed of a motor, you use PWM. So while the signal itself is digital, switching between 0V and 3V, its effect can be analog, making it a way to achieve analog-like control using a digital pin. Okay. I'm still trying to understand that whole thing about um, powering an ESP32 versus sending logic. What should I say? Logic level signals. More so, I'm trying to wrap my head around why an LLC can't be used as, what did they call it? Boost and buck? Is that what they said? Hold on just a second. Yeah, can't be used as a boost slash buck converter. I understand that they are both built different with different purposes in mind, but I'm trying to wrap my head around what exactly brings up the need for this difference. Because like, okay, I haven't seen boost and buck converters, but like I'm thinking of it from the point of view of like step up and step down transformers. Just a sec. Yeah, okay. I'm thinking of it from the point of view of step up and step down transformers, where logic can be, not logic, voltage can be increased or decreased using one of these transformers. I've usually seen these transformers in like AC to DC conversions, where you are able to power. That's usually how your like smaller home appliances and even like smaller electronic items get powered, usually there's some kind of transformer that or well, it's a transformer circuit, not just the transformer. It's an entire circuit that um, I think it first steps down the voltage because your wall is going to be putting out, depending on where you live, it's going to be putting out anywhere from I don't know, 120 and 140 volts to 220 or 240 volts. In my part of the world, it's 220 to 240 volts. So you can't just, directly power your device with that. It has to be stepped down. Not only that, it has to be converted from AC to DC. So this circuit handles that conversion as well. So I'm thinking of it in that way. I don't know if that's exactly what a boost converter does. Actually, let me Google that. Buck converter versus step down transformer. A buck converter or DC-DC step down uses switching PWM with an inductor slash capacitor for highly efficient so and so, so and so, so and so. Okay, a step down transformer uses magnetic induction to reduce AC voltage, requiring rectification for, no, yeah, rectification for DC, and is bulkier but offers galvanic isolation or galvanic isolation, which is a key difference between DC and AC handling and efficiency. Okay, so a buck converter would be DC to DC. That's important to keep in mind. Actually, yeah, that's important to keep in mind. DC to DC, because I do have situations where I have like a power supply or an adapter or something. If it's a PSU, like a PC power supply, usually they give you three outputs. Um, they give you 12 volts, 5 volts, and 3 or 3.3 volts. I believe it's 3.3. Usually they give you three of these, and they're all DC. But like if you have some kind of adapter for, or like, yeah, an adapter that was used to power, let's say, some kind of I don't know, I, piano or keyboard or um, um, whatever, some kind of like home appliance or electronic item or something, and it's putting out like 12 volts DC, then you can use this kind of a converter to step it down. Okay, that's a great question that gets to the heart of how these components function. The core difference lies in their purpose and the nature of the signals they are designed to handle. What was my question? Oh, LLC versus boost and buck. I'm glad that I didn't mention like step down transformer or step up transformer in general. I'm glad that I didn't mention that. Okay, let's break it down. LLC, purpose to translate digital logic levels between different voltage domains. To translate digital logic levels between different voltage domains. For example, making sure a 3.3 V microcontroller can safely send signals to and receive signals from a 5V device. How they work. Simplified. LLCs typically use active components like MOSFETs. When a signal comes in on one side, example, a 5V high signal, the MOSFET is controlled to pull the corresponding output pin on the other side. To pull the corresponding output pin on the other side low, on the other side down to its low level. Okay. And vice versa. That's interesting. So you give it a high signal from one side and then it pulls the other thing low. They essentially switch the output to match the high-low states of the input, but scaled to the target value. I don't understand this. It The MOSFET is controlled to pull the corresponding output pin on the other side down to its low level. I need to look into the idea of pulling a pin low because I've seen this term being mentioned a lot, pull the pin low. And from my point of view, that was basically just not giving it voltage, which means it's going to register as a low signal or as a low, you know, bit or whatever you want to call it. But I think I might be mistaken about that, or maybe partially right about that. I'm not sure. But scale to the target voltage. I'm also confused about how this is scaling to the target voltage because it seems like this is kind of inverting it. Because if you give you're giving 5V high. When a signal comes in on one side, the MOSFET is controlled to pull the corresponding output pin on the other side down to its low level. So like if you're giving a high 5V signal, it's going to pull the 3.3V pin low. So this seems kind of like it's inverting it. Okay, signal types. They are designed for discrete digital signals, clear high or low states. They are not designed to continuously they're not designed for continuously varying voltages. Current handling. They are designed for low signal currents, not for delivering significant power. Okay. So the circuit itself is not designed to allow you to pull that much I guess there it becomes about actually it becomes about power rather than voltage because they're both 5V, but how much power is it consuming? A simple digital signal is not going to be consuming nearly as much power um, as if you're trying to power, let's say an ESP32. What did the triangle look like? Hold on. Because we have like a VIR triangle that you can use to remember, the voltage, current, and resistance formulas. So that would be V equals IR, I equals V divided by R, and R equals V divided by I. And similarly, there's one for power as well. Power, voltage, um, current. No, power, voltage, current. Yeah, that their resistance doesn't come in. Power, voltage, current formula. I just need to look at that thing. Okay, so it's PIV. Okay. All right. So then power equals current multiplied by voltage. Current equals power divided by voltage, and current equals power divided by. Wait, what did I say the second one was? Oh, so I'm supposed to say for the third one, it's supposed to be voltage equals current equals power divided by current. So we are trying to find the power. The power would be I multiplied by voltage. If voltage is always the same, then the only thing that's changing here is the current. And if we are powering an ESP32, we are probably pulling more current than if we are sending data or like trying to power a digital pin. I'm gonna confirm this here. Okay, boost slash buck converters, DC to DC converters. To efficiently convert a DC voltage from one level to another, either stepping it up, which is boosting, or stepping it down. Oh, that's the purpose. Okay. Their primary goal is to deliver a stable, regulated power supply. How they work, simplified. These circuits use components like inductors, capacitors, and high-speed switches, MOSFETs, to store and release energy. Buck, they rapidly. I wonder if you can get like buck and boost converter in one. Let me see if that's a thing. Okay, they rapidly switch a higher voltage on and off using an inductor and capacitor to filter and smooth the pulses into a lower, steady DC voltage. They rapidly switch higher voltage on or off using an inductor and capacitor to filter and smooth the pulses into a lower voltage. Okay, then boost. They use an inductor to store energy from the input voltage and then release that stored energy combined with the input voltage into the output capacitor to create a higher DC voltage. Okay, give me a second here. So, signal type. They handle continuous DC voltage levels and are designed to deliver a stable, regulated output even as the load, the device being powered, changes. Current handling. They're designed to handle much higher currents than LLCs as their job is to power devices. Why an LLC can't be a boost slash buck converter? Energy storage and regulation. LLCs lack the essential. Yeah, okay, these work in different ways. Yeah, yeah, these work in different ways. Okay, LLCs lack the essential energy storage components like inductors needed for voltage conversion. They don't store energy to create a higher voltage or manage energy pulses to create a lower stable voltage. They simply translate existing logic levels, continuous versus discrete. LLCs are optimized for the fast switching between defined high slash low logic states. They aren't built to regulate a continuously varying voltage that might that might be required for powering a component. Power delivery. LLCs are designed for signal lines which carry very little current. They simply don't have the capacity to deliver the significant current needed to power a microcontroller like an ESP32 or other components. Trying to draw too much current from an LLC would likely damage it and wouldn't result in a stable regulated power supply. Efficiency versus stability. Boost slash buck converters are specifically designed for efficient power conversion with stability under varying loads. LLCs are not designed with these requirements in mind. Where was I? In mind and would likely be inefficient and unstable if used for power delivery. Okay, so I'm a little confused about uh, what you said about how LLC operates. You said that 5V high leads to 3.3V low. Explain that because it seems like an inversion. Also, explain to me what exactly it means to pull a pin high or low. Also, um, I'm kind of starting to understand the power thing. Uh, would I be right to say that LLCs, LLC versus um, boost slash buck converter is more of a power thing, as in LLCs are not meant for use cases where you need a lot of power. Um, and for those cases, you should use a converter, a dedicated converter instead, because it seems to me like in the case of powering an ESP32, the current draw would be much more than if you were trying to do logic level communication with GPIO pins. So if we are using P equals I multiplied by V, as I, no, if, no, how should I proceed with it? Assuming V is always, actually, yeah, here V is always the same. Considering V is always the same, if I increases, P increases. Thus, if P is high, we should go for a converter, else go for an LLC. Would that be a fair assessment? Man, I was supposed to be doing this shopping list preparation thing, and I started doing research on LLCs. You're asking excellent. Hold on. Was I right about my this thing? What does it mean to pull a pin high? Okay, okay. LC versus so and so. Yes, your assessment is fair and accurate. The core difference and the reason for the distinct designs is precisely about power delivery versus logic signal translation. Logic level converters, the focus is ensuring digital signals can communicate reliably between components operating at different voltage levels. Current, they're designed for very low current signals. Think of the tiny amount of current needed to simply signal on or off to another chip. Power, they do not deliver significant power. Use cases communicating between a 3.3 volt ESP, ESP32, and a 5V sensor. Okay, interfacing with I2C or SPI devices that have different voltage requirements. You know what? Actually, I do have. So years ago, I'd been gifted when I'd been gifted my first Arduino Uno. I was also given a sort of multiple projects in one. I forgot what, I don't know, maybe it was 10 in one or 5 in one or something. There were multiple projects that you could, it was a kit that was assembled with a bunch of different components and modules, and maybe an extra microcontroller as well, but mostly a lot of components, modules, and there was a breadboard as well, and a couple of like jumpers and stuff. Basically, what you would need to build a bunch of small projects as a beginner, and a bunch of them were meant to be powered by the Arduino Uno, and a bunch of them did actually require 5 volts, not 3.3 volts. I remember that because later on when I opened the thing, at the time I was doing stuff with Arduino Uno, but then now if I want to use those, I never actually used like all of those modules. I used some of them. I never got to the point where I would actually use those I would actually communicate with those modules. I'm slowly getting to that point now because now I'm learning how to now I'm learning about these communication protocols and stuff. So now I'm actually going to be using them. There was also a I don't know if I should call it an LCD or there was a digital display of some sort. I don't remember what type it was, but there was a digital display, and I am kind of tempted to try and power, not just power, write a driver for that in Rust. But I believe I also need to handle the 5 volt conversion thing there because that is meant to be powered by 5 volts, not by 3.3 volts. But yeah, okay. Boost slash buck converter. The focus is efficiently delivering stable, regulated DC power to a component. Current, they are designed to handle much higher currents, often several amps. Power, their entire purpose is to convert and deliver power, and use cases powering an ESP32 itself, powering motors, LEDs, or um, or any component that draws significant current. Okay, your P equals I multiplied by V reasoning is spot on. Logic signals, V is the logic voltage. I but I is very, very small, which is the current. Therefore, P is very low. Powering components. V is the required voltage supply, but I, which is the current, can be substantial. Therefore, P can be significant. Right, now let's go up to this and okay, I'm going to continue reading this later on. For now, I know for sure that I need this thing. So this is what I'm going to do. LLC, logic level converter. I need to write down the name properly. Where did I? Yeah, let's not call this a level shifter. What was a level shifter then? Let me look that up. Because the whole idea here. Oh, also, yeah, I want to clarify. Okay, what does it mean to pull so and so high? Okay, so to be precise, a standard bidirectional LLC translation translates a high 5V signal into a 3.3V high signal and a 5V low signal into a 3.3V low signal. The logic is preserved, only the voltage. Wait, what just happened? Something popped up on my screen. Anyways, um, the logic is preserved, only the voltage amplitude of those states changes. My apologies for the imprecise wording earlier. Oh yeah, here it's clarifying the thing. Was that an inversion? My apologies, that phrasing in my previous explanation was indeed confusing and could easily sound like a conversion. Let me rephrase and clarify how a standard bidirectional LLC works. The goal: an LLC's purpose is to translate between voltage levels, not necessarily to invert the logic. Okay, good to know that it is doing just, taking it down and bringing it up. It's not actually inverting the signal. How it preserves logic. A typical bidirectional LLC uses MOSFETs. When a 5V high signal comes in, let's say 5V, it's it signals the LLC's internal circuitry to ensure the corresponding pin on the 3.3V side is also driven high. When a 5V low signal comes in, it signals the LLC to drive the corresponding pin on the 3.3V side low. The same logic applies in reverse. 3.3V high results in 5V side being high. And okay, so this is like actively communicating, like it's actively bidirectional communication going on. So like as long as you have the thing powered, um, whatever is happening on the 3V side is going to be happening on the 5V side as well. So if one is low, the other is going to be low, just at like a different voltage. If one is high, the other is going to be high, just at a different voltage. Actually, low, not at a different voltage, at the same voltage, but high, yes, at different voltages. Okay. Then what does it mean to pull? Oh, wait. Yeah, I was reading. I was supposed to be working on this thing. Yeah, let me look this up. Level shifter versus um, logic level converter. There's virtually no difference. Level shifter, logic level converter, and voltage level translator all refer to the same essential device. Okay, all right. That's all I need to know. So, where's my cursor? Here. Get rid of this and get rid of that. Um, let's say bidirectional. That's important to have there. Bidirectional logic level converter. Now, what is the price for this? Would it be safe to say I can get 10 pieces because like their top sold thing, this seller has sold like 1,000 of these. Their top sold thing, I can get it for let's say around $5. Maybe I can round it off. So let's say 10 pieces for 5 USD. Okay, then soldering tips. 900M tips. 900M soldering tips. I should specify that because I think welding tips are a thing as well, and they probably have like a different material. I don't know anything about. Oh, soldering 900M Ti. I think Ti is also a thing there, but 900M is definitely a thing. Not Ti, 900MT, I think. But yeah, you get these tips. Copper tips. Copper tips would be great actually for especially if we are talking about heat transfer. Copper tips would be great. I just don't know about the lifespan of copper tips, and they're also more expensive. Like the same thing, if I go for other types of tips, I don't know what the other tips are made of because they just say soldering iron tips. But yeah, I can get the other ones like super cheap. There's like 5 pieces that I can get. Oh, actually, yeah, I could pick a specific one because I have with this soldering station that I got, I did get some replacement tips and there's multiple shapes. So it's not exactly replacement tips. They are just different shapes in case you need for like, different soldering purposes. So what I need to do is I need to pick one or two general shapes, and then yeah, I need to pick one or two general shapes and order just some of those. Nothing more than that. Let me sort by orders and see if there's any more. Okay, so there's someone here selling a 12-piece set of a bunch of different shapes. So I can go for I can either go for this, or I can go for this, like, specifically, 5 pieces of this shape, 5 pieces of that shape. I also need to look at the size because it mentions 33 mm. I need to make sure that I'm ordering the correct size. I need to do a little bit of research on these tips. Fortunately, the manual does also mention which tips are being used. That's how I found out that these are 900M tips. And this is what I was talking about earlier. I think a couple of days ago, I was mentioning that there's a certain standard that's followed, and like this is what I was talking about. So they gave me a certain standard that I can look for, and based on that standard, I can then buy specific tips. But yeah, I am curious to try out these copper tips. It's just that they're a little on the pricey side. At least I'm assuming good quality ones are a little bit on the pricey side. But yeah, I'm pretty sure if they're copper ones, then they're gonna do a great job. I don't know how long they last. That's another thing. I'm pretty sure the maintenance for both of these tips is gonna be slightly different because they mention for like one sort of hackish method of preserving your older tips, not even preserving, but like making your older tips last a little bit longer. There are people who advise against this, but some people say that, yeah, you can get a little more life out of it, or a little more use out of it, is if you scratch the upper surface and reveal the copper at the bottom, and then you tin that copper, and then you can use it for a little longer. But then there are people who are saying that if you do that, you're getting rid of the upper protective surface, and because you're exposing copper, this thing is going to go bad much quicker. I don't remember what exactly the issue was. I don't remember if copper just rusts much more easily, or if the oxidation layer becomes worse than regular tip surfaces. I don't remember exactly what the logic was there, but they were saying that, yeah, when it's bare copper, then you need to be like super careful with it. So I don't know if I should be going for the. I mean, it's not like I do like a whole lot of soldering right now. I think I can go for the cheaper ones. I have found cheaper ones. There's these 5-piece assorted ones, not assorted, 5-piece specific ones. Um, Hold on. What am I looking at here? I could keep around $3 for this. It's anywhere between 2.5 to $3. Check size thoroughly. How do you spell that? Yeah, whatever. Um, 5 pieces for uh wait. Yeah. So we're getting like 5 pieces for about $1. So we can say 1.2 USD um, by two shapes. So we can then make that 2.5 USD. UCS USD. Okay. Then shift register and logic gate assorted box. I did find, so I was looking for shift register specifically, but then I found a box of like assorted ICs, which includes logic gates and I think one or two other things. I don't remember exactly what they were, but um, they include the shift registers as well. But in other than the shift registers, they also include those other things. So I can see what the price is for that. There was, hold on, what was the specific shift register? Okay, let's say ESP32 shift register. What was it? This one? 74H595. I think so. Maybe, possibly. 74H595. And I need the S variant because there was a difference between the S and the regular one. I think the regular one had like a flickering kind of issue, whereas with the S variant or whatever the other variant was, I don't remember if it's like an S or something else, but with the other variant, you had the option to populate a certain buffer and then push all of that buffer's contents out at once, so you don't get like a flickering sent at once. Uh, yeah, let me look this up. 74HC 74HC 595 shift register. Okay, so we have two different types of shift registers. One of them is an SMD on like a breakout board kind of thing. And the other, which I think I'm going to be going with that one instead. The other one is a dip package. So it's like an IC with legs. And initially, I'm going to be doing a bunch of stuff with, what do you call it? Initially, I'm going to be doing a bunch of stuff with the breadboard. So I definitely need something that I can put into the breadboard. Another issue with the SMD package is that the SMD package has pins on three sides of the board. If it was on only one side, or even on two sides, um, I would be able to fit it onto my board, onto my breadboard, and use all of the pins. But in this case, it becomes a little bit, the design becomes a little bit weird. So I don't think I'm going to go with the SMD version. I wasn't planning on going with the SMD version anyways. I was planning on going with the dip version anyways. Um, but there was like an assorted box of stuff. So let me also look that up. Let me sort by order. Yeah, 5 pieces. Okay. What all are we looking at here? Though this is only gonna give me 5 pieces, and then I'm gonna have those logic gates, which am I'm not sure if I really need it. Yeah, I'm not sure if I need it. I could instead use 10 pieces of this. Though, hold on. Let me try asking. Gemini. Give me a second here. Oh, I need to remember about this project case thing as well. Okay, I'm looking to buy shift registers, specifically 74HC 595. Did they mention S? Wait, let me look up these other. Okay, I'm just gonna feed this into Gemini. I found no browsing online. I found um, a box of assorted ICs containing the following. Tell me what the other ICs are, and then I have some questions. Okay, a box full of 74HC series chips is like a Swiss Army knife for electronics. The 74HC 595 you're looking for is a classic for expanding output pins, but several other chips in that set are equally useful for logic and data management. Here's a breakdown of what each of those ICs does. The logic gates. Okay, so there's NAND gates, NOR gates, inverter, hex inverters, AND gates, OR gates, and then there's something called a hex inverter with Schmidt trigger inputs. Then the function ICs. One is a decoder or a multiplexer. You give it a 3-bit binary number and it picks one of the 8 output pins to turn on. It's great for selecting which device to talk to in a larger system. Okay. Uh, just a second. Okay, then there's serial in, parallel out, shift register, parallel in, serial out, shift register, and of course there's a decoder. Okay, so well, I do hobby electronics with ESP32 and Rust. Do you think those other ICs would be useful for me? Because I mean, to be fair, it's not like I am building a massive project in which I would need like a bunch of uh, shift registers. One shift register alone, it's got like 8, I think, 8 outputs. So like that alone ends up being like more than enough. Since you're working with ESP32 and Rust, this kit is actually a fantastic troubleshooting and expansion toolkit. The ESP32 is powerful, but it has two main weaknesses: a limited number of GPIO, um, a limited number of GPIOs, especially if you use Wi-Fi and Bluetooth. I didn't know that it becomes limited if you turn on Wi-Fi and Bluetooth. I should look into what's going on there. And a sensitivity to voltage, noise slash weak signals. These chips solve those exact problems. Here's how here's how you would use them in your Rust projects. The input expander. Where was that mentioned? Um, just a sec. Oh, is that the? Hold up. I looked up shift register. I just realized there's a chance that the specific thing that I was looking for isn't even in. Yeah, I'm just realizing this now. Um, the specific IC that I was looking for, no, it does say 595. Does it mention it here somewhere? Yeah, it does say 595. Okay. There's 10 in total. Okay. All right. Hold up. So Gemini mentioned one, two, three, four, five, six. Okay. Then there's the multiplexer, seven, one shift register, eight, another shift register, nine. But this shift register is okay. Since you're specifically looking for the 595, it's worth noting how it compares to the 164 in that box. Why did wait, did I not mention 595? Is that Oh, okay, no, the box does have 595. It's just that Gemini didn't include it. 595 is good for output expansion. 164 is great for simple output expansion, whereas 595 is great for output expansion for stuff like LEDs and displays. Then latch, yes, it holds the output steady until you are ready to update. And the other one, no, output changes instantly as bits shift. This is probably the one that flickers. The 595 doesn't flicker, I'm guessing. Tri-state, you can disconnect outputs. Okay, I don't know what tri-state is. Okay, so here's how you can use it. The input expander. While the 595 adds outputs, the 165 adds inputs. The problem, you want to connect 16 button. Oh God, what a time for the mouse battery to die. Give me a second. And I'm streaming right now too, so I can't really I can't really place this mouse in like, oh God, how do I do this? Okay, there might be some sound as because I'm using the platform on which my mic is kept. I'm using that as a mouse pad right now. Okay. Um, okay, the problem, you want to connect 16 buttons or a full dip switch panel, but you don't want to use 16 pins on your ESP32. Okay, the Rust connection. You can use the embedded HAL SPI traits to read data from this chip. It's perfect for building custom controllers or macro pads. All right, the signal cleaner. Um, the 74HC14 is a lifesaver for ESP32 hobbyists. The problem, long wires or mechanical buttons create noisy signals that cause multiple interrupts in your code or bouncing. The use case, run your button signal through this gate before it hits the ESP32. It turns a messy, slow rising analog voltage into a crisp digital square wave Oh, that's interesting. That makes your input-driven Rust code much more stable. Safety and level shifting. The ESP32 and the ESP32 is a 3.3 volt device and is not 5V tolerant. The use case, if you wait, what does O8 and 32 do exactly? O8 is a AND gate, 32 is an OR gate. Yeah, I didn't take into account what their operating. I think it's between 2 and 6 volts. I remember having a conversation with Gemini about this previously. If you are interfacing with older 5V sensors, you can use these logic gates as a buffer. While they aren't dedicated level shifters, running them at 3.3 volts allows you to safely combine logic signals before before they reach your delicate ESP32 pins. Hardware logic. Sometimes you want an emergency stop that works even if your Rust code hangs. You can use so-and-so gate to ensure a motor only turns on if both the ESP32 signal and a physical safety switch are high. Is it worth the Rust effort? Using these chips with Rust is actually very rewarding because of the abstraction layers. There are there are existing crates like so and so. There are drivers for these. Holy shit. Okay. Okay. Dude, I could try writing drivers for this. That could be good Rust practice for me. That could be good embedded Rust practice for me. Okay, this means you can write code that thinks it's talking to a normal GPIO, but underneath it's shifting data out to your chips. Okay, you know what? I'm sold. I'll buy the assorted box. But this is like the only seller that's selling exactly this, but they've sold like 283 of this. So based on that, I'm just gonna like hope that I get proper working chips. And the good news is I should be able to use these as well. As soon as they arrive, I should be able to test them out. And this costs, let's say around, yeah, let's keep around $2.5 for this as well. So 2.5 USD. Oh, yeah, I need to look into the foam dispensers. Yeah, hold on. Foam dispensers. These foam dispensers are great. They're actually amazing. They're nice and cheap, especially if you're buying the plastic ones. They're nice and cheap, and they save a lot of the soap as well. So you're not using nearly as much soap as you would otherwise be using. I kind of want to buy from the exact same seller that I bought from last time because they sent us like a great product. So like I want the exact same thing from that exact same person. I'm gonna have to go and look where their thing was. They're also sold quite a few. So maybe I could sort based on that and find them. I think I found it. Yeah, I think I found it. I think so. I'm not sure. I don't know how much I should be leaving for this. Like, let's say, hold on, hold on. So one would be 2.5. So Okay, I could leave 2.5 USD for this as well. So I can get 3 in that, I guess, around 2.5 to 3 USD. We can leave 3. We can words. We can leave 3 USD for this. So far we are looking at what? 5, 5, 10, 13. So so far it's $13. What was the budget? My budget was hold on just a second. Right, my budget is around $80, let's say. 80 to $100 or 80 to $90. And this isn't all I have to buy. There's more. I still haven't gotten to the sensors that I need because I need to write those down. Um, Soil temperature sensor. I don't know if I'll go for a module for this. I don't know if, words, I don't know if I even need to. Because some of these you get them as just the sensor. You like that there isn't necessarily a need for a module. If it does come on a module, that's fine. But as in a breakout board, if it does come as a breakout board, then it's fine. But like you get them as like packaged things as well. Certain things that are meant for specific purposes, like the temperature and humidity sensors and stuff, they come already like packaged into something, and they expose the legs, and then you know, connect wires to that or whatever. So I need soil temperature sensor. I need a humidity sensor. Quite often you get, not quite often, there are specific ones, specific types of sensors that include 2 or 3 of these functionalities in one. I can't remember which one it was specifically, but there was a certain type of sensor that includes like 2 or 3 of these functionalities in one, so you can use it as a multi-purpose kind of thing. So I need a temperature sensor. I need a Actually, okay, no, hold on. I need a temperature sensor. I also need a moisture sensor. Uh, Moisture sensor. And soil is unnecessary to mention here. So moisture sensor, temperature sensor, humidity sensor. Um, I don't think a light sensor is necessary. Where is that? Um, Hold up. Oh, here it is. Wait, is this the one? I don't. No, it's here. Right. I could rename this file and save it as some text 12.md, and then uh, I can come here and cd scratch stuff. Actually, not cd. Oh, okay. Well, I guess cd. Here I need to do frogmouth. Frogmouth some text 12.md. Okay, so soil moisture, then light. Okay, we need a light sensor. I think this is the one I need to go for, BH1750. I think the power sensor was a little on the expensive side. Oh yeah, it does mention these are very expensive and overkill for home use. Lux sensor, I'll see how expensive the thing is. Otherwise, I'll just go for a simple photoresistor. though I'm not entirely sure how good uh, the quality of the output is going to be. Okay, yeah, light sensor. Okay, ambient temperature. Yeah, so these are the sensors that I was talking about. It mentions here that okay, they are cheap digital sensors that measure both temperature and humidity. Okay, all right. Then relative humidity. How to measure, same sensor, okay. Part two. This I'm gonna have to hold off on it because I read this and I am interested in these topics as well, but the analysis methods and the sensors required for this are they are pretty expensive. At least for my very small budget, they're pretty expensive. Finally, for another purpose, I need a water level sensor. Yeah, I need a water level sensor. I have a bunch of relays already. I don't think I need any more relays. Mic and mic module. Okay, let's open up a new Gemini instance and ask another question. Actually, I think I'm done with this uh, box thing, the assorted box thing. So I can just reuse this. Okay, what was I gonna ask? Mic. Okay. I'm doing ESP32 projects with Rust. So I know the reason why an amp module is required for speakers. I'm still gonna ask Gemini to explain. I kind of want to get Gemini here to explain it to me, so it'll be shown on stream. Let's let's uh scratch stuff, empty, open up Gemini. I need to make sure to use the flash light model. Okay, model, right. I'm doing ESP32 projects with Rust. Let's say I'm doing projects, I'm doing hobby projects with ESP32 and Rust. I want to try doing stuff with sound. Um, I've read that trying to power a speaker off an ESP32 is a bad, not power, drive. Trying to drive, not driver, drive. I keep having to go back. Trying to drive a speaker off an ESP32, okay, is a bad idea because it's gonna pull too much current slash power and destroy the pin. Instead, we should use a dedicated. Actually, I had a conversation about this with Gemini elsewhere. Um, maybe it was in this directory. I don't remember. Okay, okay. Anyways, we should use a dedicated amp module to drive the speaker. and send data from the ESP32 to the amp, so it can then drive drive the speaker. I keep writing driver. I've also heard a similar thing about a mic and mic module. I would like for you to help me understand this whole thing. Um, how do these devices and modules work? Why are the separate modules required? For my hobby projects, simple synth, simple voice recorder, etc., which cheap modules and components should I look for? I've already looked into this and I found nice cheap ones. I just don't remember what they were, so I'm just gonna get Gemini to tell me again. Um, which cheap com which cheap modules and components should I look for? Now, in terms of questions, okay, I would like for you to help me understand this whole thing. How do these devices and modules work? When are the, not when, why? Why are the separate modules required? Um, yeah, that's it. Okay, what more was in this list? Oh, yes, I need to look for a piezoelectric speaker. And I know for sure we can get them for cheap. Piezoelectric. I need to look for a specific one too. Um, Piezoelectric buzzer, I guess I should be saying. Oh yeah, look at that, dude. There's a pack of like 5, 10, 20, and I can get that for like $1 or $2. There is this thing about active versus passive, and there is also like different um what do you call it? Different materials that they are built with. So I need to see which one I want to buy. But these are pretty cheap, so we should be good. Okay, there's an active buff, not buffer, buzzer. There's an active buzzer and a passive buzzer. I need to see what the difference is between them because I do remember there was a slight difference. Okay, I think I remember looking into this one, Max 9814 for the mic, and um for the speaker, hold on. For the speaker, I think I looked at this one, LM386. I can also look at that one later on, PAM 8403. But I've looked at LM386. I do remember that name. It's a classic, very common and simple mono amplifier. It's low power and easy to use, often requiring just a few external components, which are usually already on the module. Good for simple beeps or single channel output, typically powered by 5 to 12 volts. Oh, that's something to keep in mind. 5 to 12 volts. That is definitely something I need to keep in mind. Because here we would be joining two separate voltage sources. Though, okay, keep, I could limit it to just 5 volts, but like more, if I want more power out of the speaker, I'm definitely going to need higher voltage. But like the thing with high and low voltage, like mixing them together, is it becomes a little bit complicated because then you have to be very careful of like, not accidentally frying the lower voltage circuit. Okay, so I'm gonna read this. I need. I don't know if I'll buy the speaker and amp module, to be honest. I'm definitely gonna buy the piezoelectric speaker. I might buy a mic along with the mic module. Let me look that up. What was the model number? Because this thing, it's not that the mic is separate and the module is separate. The entire thing comes as one module. But like with the speaker and the amplifier, it's you have the amp module and then you have the speaker. The speaker gets connected to um, the the amp module, and then the amp gets connected to the ESP32. But for the mic, um, hold on, I'm trying to find this thing. Yeah, okay, this is very common, cheap, and easy to use. It typically has an adjustable gain. You connect its output to an ESP32 ADC pin. This is an Electret microphone amplifier module. And then this one is similar to that, but often includes automatic gain control. AGC helps to keep the output signal level relatively constant, even if the input sound volume changes significantly. This can be useful for voice recording where the speaker's distance or loudness might vary. Also outputs an analog signal for the ESP32's ADC. Okay, yeah, I was about to say that there was an issue with the DAC, but this is not the DAC we are talking about. And yeah, there is that issue, definitely. One of the issues with the ESP32, aside from the fact that it's not meant to drive these kinds of speakers, the DAC is only 8-bit, and so the kind of audio that you can push through it is probably not going to be the best sounding, the best quality. Whereas these other ones, I believe they are higher. They have a higher bit rate. They have a higher bit depth. That's what I'm talking about. They have a higher bit depth, so you get slightly better quality sound than the 8-bit DAC. I don't remember if the ADC on the ESP32 is also not that great. I'm gonna have to look into it. Maybe the ADC is able to perform pretty well in terms of receiving input. Oh yeah, I was supposed to look for. So um, one of these has an AGC. The other doesn't have an AGC. I don't know if I need an AGC, to be honest, but at the same time, I also don't know if not having an AGC would mean that I need to set up certain other components to like prevent any sort of overpowering situation. Though I think the module itself should handle that. The circuitry is designed usually with these protections in mind. So hold on. Max 4466. Max 4466 microphone module. Uh, okay, great. So we can get these for cheap as well. These are also let's just say I can get 2 to 3 of them for $2.5. I think I'll buy two. I'll buy two for 3.5. Oh, actually, I think both of them are. Uh, oh, one of them also comes with like a gain knob sort of thing, so you can control the gain of the mic. Okay, all right. Oh, okay. Give me a second here. Just a second. Right. I think we'll go to this person's stream. I don't know what they're doing. They're studying for something. I hope they don't have any settings that prevent small raids or prevent raids in general. Uh, are we good? Yes, we are good. Okay. So, who, dude, I don't know if I'm gonna be able to make the purchase today because I still have to go through this list and find all the items. Also, I need to, find the items and like note down their prices and all and remove what I don't need and stuff like that. So, uh, I guess the purchase will be either today or tomorrow, one of the two. I'm not sure. I'll see. But yeah, that's going to be it for today's stream. Um, we are on a streak again. Um, and I'm hoping the streak continues until at least New Year's. In fact, I'm considering doing a short stream on New Year's as well. Um, or rather, New Year's Eve. I'm thinking of doing a short stream then as well. It's gonna be a drunk stream, so I'm thinking maybe I'll just play games on that day. I don't know. I'll see. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.